Isotopes are two atoms of the same element that differ in the number of neutrons. So, what's a neutron? To answer this, let's revisit our friend the atom. Atoms are made up of three subatomic particles. Sub meaning smaller than, and atomic meaning an atom. And these subatomic particles are neutrons, protons, and electrons. Now, in the very center of every atom is a nucleus, which is made up of our neutrons and our protons. Protons being positively charged and neutrons being without a charge, which is why they're called neutral or neutrons. Now, around the nucleus of an atom are electron orbits. These electrons that orbit or go around in a circle around the nucleus. And these guys, electrons, are negatively charged. We call these our electron orbits. Now, something important to note is that it's only our neutrons and protons that contribute to the weight or mass of our atom. Electrons do not have this capability. They're just way too small to really have any meaningful contribution. But our neutrons and protons, if you add them together, we get our atomic weight, or the weight of our atom. Now, something that's interesting and important to note about our atoms is that all of them have IDs, right? Their number of protons are actually what make each atom or element on the periodic table unique. So isotopes are two atoms of the same element that differ in the number of neutrons. So when we look at these atoms, we can see that all of these are carbon atoms. We know this because, well, number one, you're told up here, right? But number two, and much more importantly, we can look at the number of protons. All atoms and elements have a unique number of protons, and carbon's unique number of protons is 6. Don't believe me? Let's check out that periodic table, yeah? When we look at the carbon atom here, we see it's marked with the number 6. That's its unique number. That is the number of protons that are in our carbon element. And uniquely to nitrogen, for example, we have 7 protons. Oxygen, there's 8. And helium has 2, just as examples, yeah? So each element has its own unique number of protons. It's what identifies the element. Now, when two atoms, right, of the same element differ in the number of neutrons, they are called isotopes. So let's look at this example with carbon. Remember, the atomic number is the number of protons and is the defining character of that element. So all carbon atoms always have an atomic number of 6, but the neutrons, the number of neutrons can vary. Carbon usually has 6 neutrons and 6 protons, meaning it has an atomic mass of 12. But on rare occasions, some carbon atoms can have 7 or 8 neutrons, right? Along with their standard 6 protons. And this causes their atomic mass to change. So if we look here, we can see carbon 13 tells us that this is a carbon atom with an atomic mass of 13. That tells us there must be 7 neutrons instead of 6 in this carbon molecule, right? Because atomic weight or atomic mass is determined by the number of neutrons plus the number of protons. Does that make sense? So while atomic number, meaning the number of protons, is always the same, the mass can change depending on the isotope. So why does this matter? Atoms of the element with more neutrons than protons, so for instance having 7 neutrons and 6 protons, or 8 neutrons and 6 protons, these are unstable molecules. They can break down if they lose protons, they would actually change to a different element. This means they are radioactive. And radioactive isotopes decay spontaneously. They lose subatomic particles and energy. This is one of the reasons why we need two numbers, right? Our proton number and our neutron number. So in short, atomic number, the number of protons, defines the element, and atomic mass, protons plus neutrons, tell us which isotope we're dealing with, right? Carbon-12 versus carbon-13 versus carbon-14 as just examples. And if you're curious, extra neutrons actually exist in nature due to the decay of atoms. So if we're looking at this carbon atom as an example, right, we're dealing with an element that has to have 6 protons because all carbon must have 6 protons. Let's say we're dealing with an isotope of the carbon atom, right? So we're dealing with carbon-14 instead of carbon-12. As some practice, how many neutrons are in this carbon atom? This carbon atom that is an isotope of our carbon-12 atom. Remembering neutrons plus protons are our atomic weight. Right, it'd be 8. We'd be dealing with 8 neutrons because 8 plus 6 is 14. Does that make sense? So now let's have you try one of these problems on your own for your very first check-in for this lesson, okay? So check-in number 1, I want you to go ahead and tell me how many protons would be in an oxygen-19 molecule, right? And I've circled the oxygen element for you on this part of the periodic table. Check-in number 2, now that you've told me the number of protons, how many neutrons would be in this oxygen atom, this oxygen-19 atom? Check-in 3, are these two molecules isotopes? Really think through this, looking at our protons, neutrons, electrons very carefully. Are the two presented molecules isotopes? How about these? Check-in number 4. Are these two molecules isotopes? And now let's apply what we've learned a bit. This is a more narrative format of a check-in question, so let's get into it. A group of students, Jimmy, John, and Joe, while wandering through the woods, came across a dense black substance with a slight shimmer to it. Jimmy picks it up and they all walk back to the chemistry lab to analyze their fun new find because it just looked so cool. While waiting for analysis, Jimmy starts feeling nauseous. So John walks him home. Joe stays behind and discovers that the substance they found is made of pure carbon. The atomic analysis produces the following results. Question number 5. How many neutrons are in the carbon-19 atom? Question number 6. Using what you've learned from this lesson so far, why do you think Jimmy got sick? Use relevant vocabulary from this lesson in your answer. And here's just a reminder of the molecules found during our analysis. Congratulations! You have finished the first part of this lesson.